Now, Heshini Dalpathadu is a graduate of Western University's Bachelor of Medical Sciences program and is currently in the 3rd year of her PhD in medical sciences. Her passion for pediatric research was ignited by her early volunteer work in hospitals and with underprivileged communities, where she saw firsthand the impact of healthcare disparities on children. These experiences inspired her to drive to contribute to improving the health and well-being of children through research. Heshini's PhD project focuses on a condition known as cardio-renal syndrome in the pediatric population, where she investigates the effects of kidney toxins on the heart using heart stem cell-derived heart cells. Under the supervision of Dr. Stephen Greenway and Dr. Andrew Wade, her work aims to improve outcomes and treatments for children affected by this condition. Heshini has presented her research at several local, national, and international conferences. And in fact, she actually just flew in yesterday after presenting at the American Society of Nephrology's Kidney Week, which is the largest international kidney conference, which is super cool. She is also a student lead in the Libin Cardiovascular Institute trainee organization and was a finalist in the 2024 3-minute thesis competition. Beyond her academics, Heshini co-founded 2 initiatives at the Foothills campus, one providing free menstrual products and another offering support to neurodivergent graduate and medical students. Her long-term goal is to bridge bench research with patient care to drive advancements in the health of children with heart conditions. When she's not busy in the lab, Heshini enjoys baking, embroidering, and making science videos on TikTok. So please welcome Heshini Dalpathadu.
Every time I walk into the Alberta Children's Hospital, I feel so inspired by all the little lives that are being saved, but also overwhelmingly sad when I see the painful experiences of these children. Last time I was there, I saw a little boy, no more than 5 years old, dwarfed by a dialysis machine which looked like a massive monster next to him. This is life for a child with chronic kidney disease. As if his life isn't hard enough, he also suffers from heart failure. In fact, heart problems are the main cause of death among children with chronic kidney disease. Studies have speculated several causes for the connection between the kidneys and the heart in adults. But what about the kids? Children typically don't have the same heart risk factors that adults do, like high blood pressure. So current treatment guidelines for these kids is based on research that's been conducted in adults. Now, if you're thinking, that doesn't really make any sense, you're right, it doesn't. There are distinct differences between adults and children when it comes to disease causes, symptoms, and treatment. My PhD research seeks to answer these questions. Now, imagine the kidneys like a fish tank with a filter. If the filter isn't working properly, toxins build up and the fish die. Similarly, when the kidneys of a chronic kidney disease patient becomes less efficient, a group of harmful substances called uremic toxins build up in their blood and damage the heart. I want to know which of these toxins are responsible for the heart issues found specifically in children, how much extra toxin accumulates compared to healthy children, and how exactly these toxins affect the heart. So this is where my research comes in. First, I measured levels of these toxins in blood collected from children with chronic kidney disease. This graph highlights the relationship between toxin levels and heart function. As you can see from the dark blue bar, children with healthy hearts had low levels of this toxin. However, in children with heart conditions, the toxin levels spiked, as shown by the orange bar, suggesting a strong link between higher toxin levels and worse heart health. Interestingly, Once these heart conditions were treated with medication, the toxin levels dropped back to normal, as indicated by the light blue bar. Similar to this graph, I measured several different toxins in our patient population. This will allow me to create a reference guide that is both relevant and specific to children. But these patients already have the disease. Is it possible to use toxin levels to predict and prevent heart failure before it ruins another childhood? To answer this question, I'm going to take my previous findings and apply them to stem cells. Stem cells are a powerful tool because you can turn them into any cell type you want. I'm turning them into beating heart cells and looking at how these toxins change cell structure, cell function, the health of the cells, and how the cells talk to each other. In this experiment, I took the toxin levels I measured from real patient samples and added those same levels to these lab-grown heart cells that mimic heart cells in the human body. Before the toxin was added, the cells were beating at about 50 beats per minute. But after 24 hours of being exposed to the toxin, the beating rate dropped to about 25 beats per minute. This showed us that these toxins are seriously slowing down the function of these cells, affecting their ability to beat normally over time. I'm doing this work because research often treats kids like little adults, if they're even remembered at all. My findings will benefit the development of treatment guidelines for children, and my methods will provide a preventative, non-invasive indicator of heart issues in kids using a simple routine blood collection. At the end of the day, our goal is to improve the quality of life for affected kids so they can just be kids. Thank you.
Thank you, Heshini. That was fantastic. We have a few questions for you. So first of which, how do you transform stem cells into heart cells?
That's a great question, Jamie. It's a very complicated process, as you can imagine. Before I answer the question, I'll give you a quick analogy. So if you think of the blank pieces in the board game Scrabble, that's pretty much what stem cells are like. You can tell it what you want it to be, and it will be. So in our lab, we take these blank Scrabble pieces and we tell them, you're going to be a heart cell, and that's exactly what we do. So we expose them to specific specific compounds and reagents and environmental conditions that drive them down a path towards becoming a heart cell, which mimics what happens when our bodies are undergoing development. And these cells are very cool because they, over time, start to resemble actual heart cells to the point where they're even beating on their own. And this process is really great because it allows us the opportunity to study heart diseases in a dish, and we have the ability to add toxins and drugs that we can't really do with actual living human patients. So, yeah.
Thank you. Now, what has been the most challenging aspect of your research, and how have you overcome it?
Okay, so this is related to my previous answer because I would say the most challenging part was learning the process of growing these stem cells and transforming them into heart cells. Like I said, it's a very complicated and rigorous process, and these cells are literally like children. They need constant care. If you've seen any of my videos on TikToks, I'm in the lab every single day on the weekends. I don't get any days off. This is because I have to come in and change the media for these cells, which is the nutrient solution that these cells grow in, and it needs to be replenished every 24 hours. And with the stem cells, it's very specific, and also it requires a lot of patience and attention to detail, because if you even make the slightest mistake, everything is just down the drain, and that's months of work wasted. And the other thing too is you can follow the protocol to a T, and stem cells will get very easily contaminated. So very, very sensitive process. And another thing I want to note is wet lab research is not only physically demanding, it's also very mentally exhausting too. It can be disheartening when your cells just randomly die. So over the years, I've learned to tweak and optimize my protocol to the needs of the cells. And also I've built a routine, and I've also learned to be flexible when things don't go as planned.
Thank you. Now, you mentioned that you have built a following on TikTok for your science videos. So how has that platform helped you communicate science to a broader audience?
I think TikTok is a great and amazing digital tool. It has given me the platform to connect with a wide audience ranging from middle school students to professionals in the industry, which has been amazing. And through my TikTok, I've been able to make videos that are a few seconds to a few minutes long and make content that's easy to understand, breaking down complex, jargony science, complex science concepts and experimental techniques into a language that's more simpler and easy to understand. And the other thing with a digital platform is I can reach a younger audience. And through this, I've been able to make science more fun and exciting for the next generation of future scientists. It's been really rewarding to see comments or receive messages from middle and high schoolers, especially young girls, saying how they learned something new or they feel inspired and motivated to pursue a career in science themselves.